Avast! Welcome to CodingKoans, the show where we learn about software, we explore the wide world of software development, we get better jobs by getting onto hearty crews, where, oh man, I had this a second ago and now I've dropped it again. My name is Carroll. We're going to explore the world of software development, get better jobs, and change the world by learning how to program. So that's the show. You might wonder why it is that I'm dressed like a pirate this time. Well, when you see my guest, you might know. If not, we'll explain it further. So my guest today is Douglas Charles Hampton. He is an improviser, writer, and self-proclaimed Renaissance man in training. He spends most of his time living in fantasy worlds created by himself or others. He likes to learn new skills as often as possible because you never know when they can come in handy. Doug, would you mind showing your video? And they can hear you.
Oh yeah, you are.
Excellent. Douglas, welcome. Already, I see people screaming your name.
Really?
Yes, really.
Hello,
On the chat.
greetings.
Hellfire!
Hello,
That's what they say. Speaking of which, let's explain what is Hellfire, and why is it that someone in the chat is screaming about Hellfire?
So Hellfire is the pirate character in the show that I created, Sea of Suggestion. It's an improvised pirate adventure that it's set characters, but they improvise a new story every time. I like to think of it, you know how Indiana Jones is a set character, but he has different movies? It's sort of like that, where we have the set characters, and each show is essentially a different movie or novel or whatever. And so it's just an improvised pirate adventure. And Hellfire is the owner of the ship. He refuses to be called captain.
Yeah, that is so cool. So when you say improvised, do you mean that like you guys know who your characters are, but you don't
Yes.
you don't know what the story is going to
What's
be
going to
about?
happen? Yeah.
I
We
think
don't know what's going to happen at all because there have been, in some of our past shows, there have been things that really are very unexpected.
some things surprise you. What's do you have a favorite thing that you were surprised by in one of the shows?
Well, one of them I got shot in the face. So,
That doesn't happen in Indiana Jones very often.
no, no. Usually the heroes stay alive, but in ours, they can die.
And then they can
I
show
wouldn't
up the
really
next.
call us, I wouldn't really call us heroes either.
Uh, no, it's kind of an anti-hero. I mean, you are pirates after all, right? You did a lot of research for
Yeah.
that too, right?
Yeah, well, I've researched pirates for most of my life. Um, Actually, this flag is
Uh,
from when I was sailing in Key West, and that's when I went to It's now closed, but there was an international pirate museum. And the person that owned the ship, he made his own flag for the ship we were on because he was also a pirate, and that's when I started really getting into pirates. I liked them before that because of like Treasure Island and stuff, but
uh-huh,
it was that moment where I was like, oh, this is cool because I learned a lot from him, and then I learned
uh-huh.
a lot from the books on his ship. And I was also it was also one of those moments where he actually owned the ship, but since it was our like cruise, we had roles assigned, and I was the captain of the ship during that
Ah,
time.
good call. See, that was training for later when you.
Yeah.
I mean, like when you're directing a show, and you were actually directing an improvised show, and you put this thing together
Yes.
yourself. Um,
Yeah.
you
The help
you
with the help of some other people too. Yeah.
Oh yeah, you can't do it without help. But the point is
Yeah.
that like that was your thing, and you got together a
Yeah.
crew to help you, a bunch of people
Uh-huh.
who are experts at what they did.
Yeah.
And yeah, that's so cool. So you wait, you also you do a lot of swimming as well, right? It's not like the only
Yeah. I'm
thing.
also yeah. Pretty much anything dealing with water, I've done it, except for what is it? The water skiing. I've never water skied.
You never water skied. Okay.
No.
Well, not a common pirate thing to do, except unless you're in that
No,
one
but
Kevin Costner movie.
yeah, but swimming is a very prevalent thing in our family. So And I've also been a swim instructor since I was 15, doing like swim instructions on and off. And I'm so almost 15 years.
Wow. You
No,
spent
I'm older than that. 16 years.
you spent a lot of time in the water
Yeah.
or on the water. You know how to sail?
Yeah. Yeah. So during that thing the adventure in Key West I was telling you about, I got to sail the ship. But even before that, I learned how to sail small boats, sunfish,
Uh-huh.
at a camp, and I used to teach the sailing merit badge at a scout camp.
Oh, that's really cool.
Hmm.
So,
Taught sailing, rowing, and canoeing.
uh, all right. Arlo Sanders has a question for you.
Okay.
What is your favorite body of water?
Does he mean like in general, or does he mean a specific one?
I have no context to give that to you. You're going to have to interpret it however you're going to feel like it.
Okay, that's a good because when it comes to like, I'll answer both because when it comes to
Specific
type
is what
of
he
like
said.
specific,
Yeah.
as in like a named location, basically,
Yeah.
I'd probably have to say the Great Salt Lake. It's just
Oh,
a fascinating thing that like there's a saltwater lake in Utah, and it's just like how did that happen? There's also a movie called Pirates of the Great Salt Lake that I it's a very unknown movie, but I think it was done by Kirby Hayborn, which some people may know in our
mhm.
community. Um, and basically, it was one of those movies where I was like, this is the dumbest and funniest movie I've seen, uh, because it's bizarre.
Oh man. So also, we got more questions for you. Your favorite swim
Oh,
stroke?
okay. Butterfly.
Okay.
That's easy. That was my stroke in high school.
What first got you into computers?
Ooh, good question. So at a very young age, I I'm one of those kids that had encyclopedias in my room, and I would look up stuff going like by basically like when I was curious about something, I would look it up in an encyclopedia.
Hmm.
And then I discovered that you can do that online. Because I was born in '89, so like internet wasn't as well known, wasn't
Right.
as widely used back then
Yeah.
as like growing up. So I think I was like 6 or 7 when I first started using computers, and that's when I discovered that you can do things a lot faster with a computer. And that's when I started getting into using computers. But when it came to like building stuff, do you remember those websites? I think it was like GeoCities or whatever. You could build like a website,
Hmm.
like a very
Yeah.
basic website. And originally it would be like a template, but then there was like a version where you could use HTML or CSS.
Uh-huh.
That's when I think I was like 12, and when I discovered you could build your own website that way without using the template, so you could basically like, break the mold. I was like, oh, this is great.
Yeah. Yeah, you're already doing it. Wow. And knowing how to sail and the technical things that go along with sailing, like the
This
I
is
don't
this is
I don't know all the terminology, so please careful with the sword.
go for it.
But um, so
Better get it right.
I'm actually intimidated right now, and you are 3,000 miles away, and it doesn't matter. I'm scared. um, there are so many lines, sheets, sails, parts of a boat, and they all need to come together, and you have to know how all those parts work in order to properly sail. Am I right about that?
Yeah, that's correct.
So I'm thinking that the same set of skills that you learned for knowing how to sail are going to be similar ones to how to program.
Yeah. When you break it down to like the like if you break it down to like the skeleton of learning kind of thing,
Hmm.
it's essentially like the same kind of like template is used for learning programming as it would be for learning something like sailing.
Yeah. I guess what I'm trying to get at is uh, what seems to not have anything to do with software, is something that is prepared you to learn and something
Yeah.
that you can use.
Yeah.
Cool.
Because sailing is one of like those, because software is everywhere,
Yeah,
even in some sailing, but like
true,
sailing is one of those things where it's like it's before the computer, it's before the digital age, so it's very analog.
true.
Like they learned how to do it without having any type of digital technology. But even using those, having those skills of learning how like things work together is very helpful, even in something that is completely modern, such as programming.
Right. Yeah, it's the same kind of thing. We're just sailing a digital ocean. DigitalOcean
Yeah.
is not a sponsor of this podcast, and this is not a
Is that a thing?
podcast. Yeah, DigitalOcean is a thing. It is a data center for hire that you can use to put your software up on the internet.
Oh, okay.
Yeah. However, they're not sponsoring us, so I just wanted to mention that. Yeah, there's a number of analogies to seafaring life with software. I frequently said that it is an ocean of knowledge that you have to sort of navigate.
Yeah.
Yeah. But I think it's about time for us to transition into what we're going to be working on today.
Great.
And we're going to be working. Okay, so I got a couple of bad pirate jokes for you. Ready?
Okay.
Okay. Did you see the new pirate movie?
No,
It's rated R.
I saw that coming.
Yeah, you did. So, what's the what programming language is a pirate's favorite one?
Which one?
Well, some would say it's R, but it's not. His true love is C, and we're going to be working in C today. So that was my transition. Yay! Thank you for riding along with me while I did that to you. Thank you,
Yeah.
audience, as well.
I hope it wasn't totally obvious that I hated it.
No, it was pretty obvious, and I think everyone should feel good about the fact that you all should hate that because it was terrible. So let's go ahead and work on the next thing. So we're going to be doing C programming, and I'm going to share my screen with you.
C. I've never used C before.
I haven't used very much of it either, but I did program with C a while ago when I was first learning software.
Okay.
I decided to learn C, and C is a very old programming language. It's from the 70s.
Yeah, I've heard of C before. I've heard of it. Like the joke is kind of like that C is the one that like started everything, but no one uses because it's so daunting.
It is a very daunting programming language, and the reason why, much like the difference between sailing a boat and I don't know, getting on a yacht where like there's all this fancy electronics and things just taking away the idea that you're actually on the ocean, right?
Yeah.
C is very close to the metal, and that's what we say in software. We say it's close to the metal,
Okay. Close to the
meaning
metal.
that it is nearer to what the hardware is doing, which means that some of the abstractions that we would use to explain things away, or to understand and get a grip on how the computer is doing things, is not available to us in C. Now,
Oh, okay.
but there are some people who say C is a very high-level programming language. Those people work in assembly. And they're basically dealing with ones and zeros and giving actual physical instructions to specific pieces of hardware. And that's the point where it's no longer portable software. C is one of the first languages that's portable. So that is that if I give you the code, the C code, and you compile it on your system, you can run it too.
Okay.
But otherwise, you would need to have the exact same hardware that I have in order to run the program.
Right. Okay. Gotcha.
Yeah. So that's what made C such a big player and such a massive shift, is that you could pass around programs. And so that's what we're going to be working on today. And we're going to be working on something called Game of Life, which is right here.
I've heard of Game of Life.
Okay. What have you heard about it?
I heard that it's a computer. It's like a computer simulation game, right?
Mm-hmm. Yes.
And it involves creating a thing where you start with a cell pattern, and then based on that cell pattern, certain things happen. Like, and there because it has certain rules to it, where
That's
like if
right.
something
Yeah.
if there's like one cell, if that cell is not, I don't remember what the actual rules are. I'm making these up. But like it's like something like one cell is in the middle. If it's not surrounded by anything, it dies. And if it's
Yes.
surrounded by one, it like multiplies or something.
Yeah. Yeah. It does like that. Here's a Wikipedia article on it. Let's take a look.
Yeah, Conway's Game of Life.
The game
And
of
you can
life.
create those things.
Yes.
Yeah, you can create those things, which are like called gliders, I think.
Yes.
The ones that are growing down in the Wikipedia article.
Yeah.
But then there's also like shooters. There's a
Yeah.
whole thing.
Yeah. There's a lot.
It's a
So basically, the
but I've
rules are
never I've never played with it before.
yeah. The rules are really simple. Um,
Oh, there they are.
yeah. Okay. So a cell is going to be like an Excel spreadsheet cell, right?
Yeah.
So it's a box, and it's got 8 around it, right?
Uh-huh.
Cool. So any live cell, that is a cell with a living creature in the inside of it, with fewer than 2 live neighbors, dies because it's lonely. That's
With
what I'm going to
fewer
say.
than two neighbors.
That's right. If it has fewer than
Okay.
2 neighbors, it dies because it's lonely. Any cell with 2 or 3 live neighbors lives to the next generation.
Okay.
It's got just the right number of people to support it. And then any dead cell, oh, here we are, another one. Any live cell with more than 3 live neighbors dies as if by overpopulation.
Overpopulation.
Right.
Oh, that's right. That yeah.
So it dies because it is being smothered by all the people around it and being oppressed by their horrid culture that they have created, a toxic culture, you would say. Yes. So
Yeah.
they either die of loneliness or ennui. We can use those terms as well, or they live because they have just the right amount of support. And any dead cell with exactly 3 live neighbors will suddenly burst into life, as if there has been reproduction happening. Now, that's interesting, because in Conway's Game of Life, unlike in our world, you need 3 to reproduce, not 2.
Oh yeah, that is interesting.
Yeah. So, um, yes, this is not the board game, Aaron Harvey. But, oh, by the way, Aaron Harvey is in the chat. He has a show on Outpost 13. It's called Infinite Trek, where he talks about Star Trek. And right now they're going through Lower Decks, which is a really awesome animated show that I've been watching like every single week, just dying for it. I love listening to his show as well, so definitely listen to his. It's on Saturdays at 11. I think it's 11. I could be wrong about that. He'll probably correct me in the chat, but yeah, Saturday mornings, which is appropriate for cartoons. Anyway, so yeah, that's how Game of Life works. Yeah, it is 11. Yes.
Oh great.
Yeah,
You got it right.
I got it right.
Congrats.
Yes. Okay, so all of this happened. That's how the Game of Life works. So I'm going to go ahead. I've cloned this Game of Life from here, and we can see. So I've cloned it from the CodingKoans GitHub organization. Yeah, it's GitHub org. And so we'll cd CodingKoans and then into Game of Life.
Cohen's.
And let's take a look at what's in there. So we have gameoflife.c. I compiled this earlier. So if I do ./a.out, that's my compiled Game of Life code. So,
Okay.
Doug, you've done Python.
Yes.
Yes. Python is an interpreted language, which means that you just run Python and give it the script, and it will go through each line of its code and go like, what's that? Okay, do it. What's that? Okay, do it. What's that? Okay, do it. C is a compiled programming language. So what it will do is it will read the whole file and then turn that into bytecode, and then that gets run as an executable file, which means that you can pass around the executable file to other people without actually exposing what the source code is.
Oh, interesting.
It also gives you a few advantages as well. Compiled code can run faster than interpreted code.
Is that because it looks at the whole thing at once instead of line by line?
That's right. It looks at the whole thing at once, optimizes the code based off of the hardware that you have, and then runs it. It's still not as optimized, by the way, as if you were to go in and deal with the assembly code itself and actually like go in there and work it just specifically for that piece of hardware, which, by the way, is what you would do if you were coding for a satellite or a space probe or a Mars rover.
Right, yeah.
You might do that instead because you need it to be running at absolute peak efficiency for the hardware that you have there. But then again, you're not planning on making a whole lot of them, nor are you planning on having it be, reproducible code. So, there are trade-offs.
Those are like one time. Yeah.
Yeah. Okay, so I'm going to run this and see what happens. All right. So here we have our game of life, and it looks like I have managed to randomly populate these little Ys. Everywhere there is a Y, that is a live cell. Anywhere where there is not a Y, that is an area of deadness. And it looks like the population is 463 right now. It gives you your max and min right here as well. How many generations do we want to watch?
Oh, let's watch 7.
That'll be quick. 1, 2, 3, 4, 5, 6, 7. And that's it. Okay.
Right.
Cool. So we got to see it work a little bit here. So let me take out the code and show you that next. So first of all, that's kind of slow, right?
Yeah.
We might want to fix that. And I think I will want to. Oh, man. See No Evil Cast says, "Why? The Last Doug, new graphic novel." All right. So normally I would use VS Code for being a text editor, but for today, since we're working close to the middle, I want to use Vim, which is an editor that exists on the terminal rather than as a separate application. It is still technically a separate application, it's just that it works through the terminal. So let's look at the code through that.
I think I've ever used Vim.
Vim is really cool because there's all these like shortcut keys on your keyboard. So if I do Shift G, I go right to the end of the file. And as you can see, it's 145 lines long, which is kind of long, but not the longest thing in the world. And then if I was to type, I believe it's just GG, I go back to the beginning. Things like that. There's a lot of shortcuts, and some people use, we talk about someone's Vim foo being very strong. Them being able to use Vim in ways that other people can't use it. But yeah, Vim is really cool. I agree, see no evil cast. Let's see here. So here's our code. I changed some things in here. So actually, I made it work. So the first thing I'm going to do is I'm going to make it not work anymore. And we're going to learn some things about that. So I'm going to git reset. Okay, first of all, let me just get status. So here are the changes I made. I changed something in Game of Life, and there's this new file, a.out. So I'm going to git reset hard. Yeah, I think that should do it. And now those things are gone. Let's call this file something new. So let's, shoot, how do I rename things? I can move it. Yeah, that's how I'm going to do it. I think if I do mv a.out, and I can go to, let's do b.out. We'll try that.
Okay.
And now there's a b.out. And
Okay.
just validate that that actually worked. Let's do /b.out. It's still working. I've changed the code, but this one is still working. And that's proven by the fact that it does this. So I'm going to Control-C out of that. Now, let's try and compile the code before it's fixed. We're going to use GCC, which is our General C compiler. It's pretty much what you would use for most things of this nature. So
it's not a community college.
No, it's not. It's not Glendale Community College. It's the GCC. And then we're going to pass it the name of our file, gameoflife.c. We're going to see it give us back some errors. Warning, implicit
declaration.
Implicit declaration of function srand is invalid in C99. And here we are, rand is invalid in C99. Here we are, system is invalid in C99. What the heck is it talking about? Well, let's take a look. So inside of our code, I believe I'm using it somewhere in here. If someone knows better Vim foo than me, by the way, you can actually search for words like this. I'm just not that strong of a Vim user. I know how to use it, but only like a noob, I'm afraid.
Like a noob.
Yep. I've never had to learn how to do it all that well. Mainly because if you write really clean code, you don't need to use a whole lot of fancy tricks. But I'm not seeing these in here. I think if I do escape, is it :%?
What are we looking for? We're looking for rand and srand.
%rand. Nope, never mind. Oh, I know what it is. I think we do it this way. Didn't find it. Okay. Well, we could spend our time doing this, trying to figure out what's wrong, or we can Google the error message. So to get out, I use :q bang, like that. Which, by the way, is one of the most common things that is Googled about Vim is how to exit Vim.
:q bang.
Yeah, it's not something that's very intuitive. Yeah, Arlo Sanders.
That's fair. I've had moments where that happens in not Vim, but where I'm like, how do I get out of this?
Yeah. Exactly, and well, you can Google that too. You can Google how to do that, but it just so happens that Google has been tracking how often people Google things about Vim, and the most common thing is how to leave.
How to leave Vim? That's funny.
So I did Google this earlier, and I found this Stack Overflow article. Implicit declaration of function free is invalid in C99. Well, we don't have function free, but it looks like these are all kind of similar: srand, rand, system. It's otherwise the same. How should I free my C structures if I can't use the function free? Did you include standardlib.h? You should include standardlib.h. All right. Did we include standardlib.h? We're including standardIO.h and time.h. Okay. So let's try and include it. Hash include.
Looks like you didn't include it.
stdlib.h. Write and quit will allow us to save and leave rather than to just leave, which is qbang. Qbang just leaves. Write quit WQ, saves and leaves. And we can confirm that. There it is, still there. Okay, qbang.
Qbang.
And now let's try and compile that again. See what happens. Oh, no news is good news when it comes to compilers. You see nothing, it means it worked.
Okay, so since no invalid came up, it means that it's working.
Yeah, and we can now see there's a new a.out down here as well, besides our b.out. And by the way, that b.out is still valid, even though we changed our code earlier, or even though we made it break and it wouldn't compile, the b.out would still run. So I'm going to go ahead and remove b.out now because we don't need it. If we wanted to A/B test these, that's how we would do it. So.
Right.
All right, cool. So, okay, so we got that first thing in there. Let's.
Get status.
We're going to get add -p. -p is going to show us exactly what code we're going to add in. Yes. We're going to stage that hunk. Cool. Get status again. And we're going to see that it's in there, modified. Great. Then we're going to add in our names into this using getDuet, which is a fancy tool that you can get that's for free on GitHub. Just look up Google getDuet. And we're going to add in our names. I believe you're under DCH and I'm under IC. I configured this earlier. And there we are. There's our names. By the way, your email is now everywhere, Doug. Sorry about that.
Send me emails.
Okay. Now we're going to get duet commit. Not just commit, but we're going to duet commit. And this is going to bring us back into Vim. And we're going to say add stdlib for C99 so that it compiles again. Git push. Now that's back onto, now that's up for everyone to see it, and now we're getting the new stuff. Okay, so let's go back into our code. All right, so we said that this was kind of slow, right?
Mm-hmm.
Maybe...
yeah, so how do we speed it up?
Good question. So let's look at what this is saying. So we're going to include these three things, and here's time.h, by the way, that we're including, so probably it's going to have something to do with that. We have a couple of rows and columns that are hard-coded here. 35 rows, 79 columns. So that's going to be the size of our board. We have a number of variables here that are set to 0 to start, and over the course of the game will change. And then we have something called a temp grid, which has rows and columns, which is an array of arrays, basically. So that makes our two-dimensional grid. You know, a list of lists. And there you are. So we're going to get our user input, then we're going to initialize that grid, then we're going to process the generation, and then we're going to count neighbors. We're going to print that grid, and then we're going to sleep. Sleep. This probably has to do with time. I bet this is what we're going to need to change. And here's our main. So we're going to, oh, here's our srand, by the way. So we're going to randomly use an unsigned integer and set time null. And then we're going to have time null over here. So we're just going to use time. And, oh yeah, that's what this is about. Time null is actually how we're seeding our random numbers. So a computer doesn't have any ability to actually do random anything. What it uses is some seed value, and then it does some fancy math on top of that to make it appear random. But it never is. If you were to give it the exact same seed, it'll produce the exact same random results, which is why it's not really random. So what we're using in our random is we're going to use the system's clock for time, and we're just going to take the number of milliseconds since 1970 and use that as our seed value, which is why it always looks random, because that's really hard to ever get the same value twice. You'd have to go back in time. I guess you could turn back the clock on the computer, but even then you have to hit exactly at the millisecond. Not that that can't be done. It can. Don't think that it can't be done. But it's hard, and we're not going to deal with that right now. We're basically
That reminds you of getting a tie in swimming, which is very unlikely, but it happens.
Yes, it is hard, but it can happen. It is possible. Not likely.
Tenth of a second.
Yeah. It might take some engineering to make it happen, too. But, all right, so we're going to get our user's input as G, which, by the way, these one-letter variables, I hate this. I hate this. This is my code. Past me? Why? Why one-letter variables? So we're going to loop through that using a for loop. I equals 0, I is less than the G, I plus plus. Generation plus plus. Okay. Process a generation, print the grid, and sleep for this long. Oh. Huh. Look at that. It takes an unsigned integer. And look at this. That's
was that 1 million? Was that a million?
A million, but that's because it's milliseconds.
Okay.
So, I'm thinking that we don't even have to read the rest of this code. We do this, you get rid of 3 of those zeros, and this is going to go real fast.
I would assume so.
Yeah, let's try it.
Because that's now 1,000 millisecond.
Yeah. So hold on a second here. Before I do that, escape, undo. Here we are at 1 million seconds. That's 1 frame per second is what we're creating. And this is basically a video that we're creating, right? What's a standard number of frames per second that we can use?
For video?
Yeah.
You're talking about like 30 FPS?
Yeah, something like 30 frames per second, right?
Yeah.
We need to kind of figure out how to divide this so that it makes about 30 frames per second.
Man.
Oh, McCready13 subscribed, by the way, at Tier 1. By the way, you can subscribe as well. And if you do, then you get to see these videos video on demand. You also get lots of other benefits as well with our community. You know, this isn't the only show that we got. Oh, by the way, Puck90 is in the chat right now. And that's Allison in Constanti, and she has a show on Outpost 13 as well. It's called Allison's Sci-Fi Library Super Fun Time. And that's at Tuesdays at 3. She reads... she's reading A Wrinkle in Time right now, and it is great. She is a great reader of books. So yeah, stop in for her show as well. Sorry, that was a bit of an advertisement. It is a great book. By the way, See No Evil Cast is asking, what would be a better option than a one-letter variable? Let me ask you, Doug, what does this G mean?
I mean, the G is a variable, right?
True.
And it's only one. The variable can be any length, right? In C.
Yeah, you can make it any number of characters. Make it large, make it small. Doesn't matter.
So I would say use a word. What is it? It's get user input.
Get user input is what we're getting. So it's not. So we're calling get user input. This is a function right here that is going to get our user input for us and return that user input and put it into this variable called G.
Yeah, it's being stored in G. So I would probably put something other than G. Something
like user input?
Yeah. I was trying to think of something other than that.
Or
trying to be clever.
Oh, look, here here's another thing. User input is one way of putting it, but we understand that by get user input. If you look down here, it says how many generations do you want to watch? And so this is the number
so it could be generation.
Yeah, this is the number of generations.
Yeah, so make it generation.
Yeah. Time is the fourth dimension according to Wrinkle in Time, and in fact we are going to be playing with that fourth dimension now as we create a whole world and allow it to flourish for a brief period before stopping time permanently. That's what we're going to do. So yeah, that was Puck90 in the chat, by the way, Doug. If that made no sense to you, why I just said that.
No, it actually did because I know that book. So
Okay, cool. Okay, so we've got a million. Is that nanoseconds? Or are we talking about milliseconds? Milliseconds is 1,000, right?
you said milliseconds before.
Yeah, I did, but I think milli is 1,000. I think it's something like nanoseconds here. So
I couldn't tell you.
yeah, but
I
based
think
off,
milli is 1,000.
yeah, it is. So if we were
Even though
to
you
get
think
rid of
it'd be a
3
million.
zeros, it would come up with a millisecond, and it would be 1,000 frames per second, which is very, very fast.
1,000 frames. Yeah.
Now, if we were to do it, if we get rid of 2 zeros, it's 100 frames per second. 1 zero is 10 frames per second, and that's kind of slow. So we're going to use the X key to just delete that right there instead of using the editor. So now we've got 10 frames per second. I guess we can make it 30 by changing this to a 3, right?
Yeah.
And now it should play like a movie.
Hopefully.
Okay, let's see if that's right.
What happened?
What?
Nothing.
Was it the boop sound? I just hit the wrong key. That's all.
Oh, okay.
Yeah.
You know the universal error sound.
Yes. So we're going to need to compile that again. So for now, we're going to remove a.out again and create a new one.
Okay.
Actually, I'm going to do that here. Let's compile it again. This is one of the things that's annoying about compiled languages is that you can change the code and forget to compile it and then go like, oh wait, why isn't it doing the thing I wanted it to do? And then realize, oh, I forgot to compile it. So now we've recompiled it. Here we are. Thanks for playing the game of life. 30 generations is going to go by in 1 second. So let's do 5 seconds. 5 times 30 is 150, right?
150. Yeah,
Okay.
150.
Well, that's not nearly as fast as I was expecting it to go. It is faster. Not nearly as fast as I was expecting it, though. Okay. So at this point,
what have you created?
I'm just going to tweak it until I get it right. I don't need to know. I just need to try. That was faster. Let's get it even faster still until we get to a point where it's feeling kind of right. So let's...
What is that? It's at 300. It's at 300,000 right now.
Yeah, whereas opposed to
what it
a
was
million.
at.
So it was going 1/3. It was going 1/3 as fast. Right, approximately 1/3 as fast. Now it's going 10 times faster. Sorry, yeah, it was going 3 times faster before. Now it's going to go 10 times faster. We need it to go even faster than that. We need it to go, yeah. That's it. Let's take a look at that. No, I don't want to compile it. Oh, it just recompiled on top of itself, I think. I think it just clobbered the other one as soon as I did that. That's interesting.
Okay.
All right. So if this is 1/10, if this is 10 times the speed, we need it to go 30 times the speed. So in order to get it to go 30 times the speed, we're going to need to do something like delete this 0, and then turn all these to 3s. So we're going to need 1, 2, 3, 4, 5 3s.
Why are they all 3s?
Because we're going to do a third. I think that should work.
Okay.
I think. Compile it and see if it moves faster. Come on, where is it? Oh, yeah, that's right. You do that. There we are.
Oh yeah, that's faster.
And you can see there are certain places where life has just become stable, right?
Homeostasis.
Nothing changes there. These little patterns are ones that always stay the same unless something gets in the way of it.
Yeah. I like the
Just
little
kinda-
hexagon down at the bottom.
Oh, down here?
Yeah, that's the first one I drew that drew my eye.
That's cool. Here's the
I shall
opposite of it
name
too.
I shall name him Blobby.
Blobby. This collection of individuals that represents a culture that is always self-sustaining is
Yeah,
named
that's the
Blobby.
Blobby culture.
The Blobby culture. Well, we're going to wipe out the Blobby culture right now by creating a whole new universe.
No.
And then we're going to run it again. 150? Sure. Let's do 300. Let's see whether or not it just gets to a place where
10,
it's
so it should be
perfectly-
10 seconds.
Yeah. There it is. Blowing up, changing around. Man, it's still going. Look at that. Takes a while for things to completely stabilize. See, it just ate that culture over there. It's going to eat that one too. Oh, we ran out of time. Time stopped.
There's also these three ones like to just stay in the same spot and basically are imbalanced because they just alternate between a
Yeah.
straight line and a vertical
Yeah.
line and a horizontal line.
Yeah, isn't that cool?
So that's a form of balance, you could say.
Yeah,
Or a form of,
that's a dynamic
stability.
balance. Yeah. Let's do 1,000. So yeah, you can see them moving back and forth. Occasionally they get eaten though. Here they are. And now everything is exactly the same forever. That stops pretty quick though.
Yeah.
They achieve stasis very early on. It hasn't changed for a while now. We would call this the heat death of the universe, by the way.
The
Nothing
heat
changes.
death?
Yeah, nothing changes from this point on.
Okay.
Everything is just cold and icy. Never
You got-
changing,
you got-
never growing.
You got dancing cultures and you got what's it called?
Static cultures.
Yeah, that's it.
Now, these might look stodgy, but they're actually dancing just as fast as these ones are. It's just that every time that one of them dies, another one is replaced. So you never get to see the pattern. These are actually moving much slower, and that's the reason why you can see them.
Interesting.
Yeah. All right. So that's some C going on there. Let's commit that, and it's about time. Actually, time went really fast. Speaking of time.
Is it really?
Yeah. Yeah, we got like
Oh,
10
wow.
minutes left. So let's go ahead and commit that. Let's do the opposite of what we did before. And let's see. Cool. Add dash P. Just change that. Yes. That still didn't feel like 30 frames per second, though. Could have probably gone faster. But, you know, close enough.
It was definitely faster than the original
Yeah.
iteration.
True. So let's duet commit.
But yeah, it seems like to get the time that you would want, you just kind of would have to keep trial and error of time based on how fast you want it to go.
That's a quote for anyone who likes Star Wars. Another way of putting this is apply pressure to the fourth dimension. Sound good?
Forgot an N.
Oh, thanks. Good thing I caught that before. Otherwise, we'd have to clean up the mess. Let's insert an N. Dimension. Okay, cool. We did not commit that a.out, and the reason why is because you want to compile that later. Speaking of which, we didn't actually say how we can compile things. So I probably should add that into our README. Let's do that real quick. going to copy that. And then we're going to vim the README. And we're going to do one thing here. Okay. It's always good to have in READMEs how to compile. Past me didn't do that. Actually, let's go a step further.
Especially in languages like this.
Yeah. Where it's not intuitive. /a.out. Yeah. That's how you would do that.
Yeah.
Okay. Get add-p. Stage that hunk, yes. Then we go on to get duet. We reverse ourselves again, do the little dance. ECH. Okay. Good. Let me tell you, it's actually kind of hard to type in these bracers.
Nonsense.
There's a reason why software engineers don't normally wear bracers, and that's it.
I mean, you trying to tell me that pirate clothing is not suitable for computer programming?
Well, I mean, it's basically fine. It's just that it gets in the way of your wrists a little bit, and just these parts. Fair. I mean, like, if I had like a soft pair of these that were made out of like I don't know, silk or some sort of cellophane. It probably would at least free up my wrists a little bit. And there we have it. And now if we go back to, gotta push that. And now, go back to Game of Life, and we will see, hopefully, see, oh god, there's so many C jokes, I'm not going to do them all. I could, but I'm not going to. We'll see our commits. Look at this. Here's the last, we just have initial commit and initial commit. This is me from July 16th, 2016. 4 years ago,
oh my gosh.
Ian had the 4-year prior version of Ian thought that was a really good commit message. 4-year prior Ian is not Ian now. Ian has learned a lot of things. I am saddened.
Is that the same Ian that made a G variable?
Yes, it's the same Ian that made the G variable. Because one-letter variables, computer programming is more about knowing English or a language that's a human language rather than mathematics. Although mathematics are very helpful, human languages are useful if you ever want to look at your code again or if you want other people to help you out. So that's my message for today. What did we learn today, Doug?
Don't do single letter variables.
You know, I didn't hear that, but the audience did.
No, but I just said don't do single letter variables.
Yep, that's one thing. We explored life in the sea.
Yeah.
Yeah.
We discussed the difference between a compiled language and interpreted language. Is that what you call it?
That's right. Python? Yeah, interpreted languages. Yeah. Like Python is an interpreted language. Oh, fun fact: Python interpreters run on C.
No.
At least most of them do. So when you're running Python, you're actually running C underneath of the Python.
Interesting.
Yeah, so Python swim on the sea. Unless, of course, you're using the PyPy interpreter, then Python is running on Python. Don't explain to me how, I don't understand how that works either. It's like a snake eating its own tail. Um, but yeah,
Ouroboros.
okay. So, yar, pirates of the sea, says Arlo Sanders. Uh, and Puck90 just asks, what is Doug?
What do you mean? What is Doug?
I don't know. That's what she's asking. What's Doug?
I'm Doug. I'm the only Doug. Any other Dougs you've seen are cheap facsimiles.
Hmm.
I'm the real one. Even ones that came before me.
Mm. So, and your favorite swim stroke again is?
Butterfly.
Cool. Glad that you kept that consistent. All right. So I have two questions for you. For towards the end of this, I'm going to stop sharing my screen now, and we're going to make ourselves nice and large so that people can see us. So, Doug,
Yeah.
what do you think is the most important thing to remember about working with software?
Ooh, that's a good question. So, when it comes to software, first off, software is everywhere
True.
in our modern world because we live in a digital age. So it's so if you think your life's not affected by software, you're wrong. Um,
True.
so that's one thing to remember is that it's a very important part of most people's life.
Hmm.
Because I will say that I guess there are some people that don't. I've been studying anthropology and learning about some cultures. But anyways, so I would have to say when it comes, what was the question?
What's the most important thing to remember about software? And you say it's
Oh,
everywhere.
it's everywhere.
So if you want to affect the world that you live in, knowing some software would be a pretty good place to
Yeah,
start.
yeah.
Speaking of which, if someone wanted to learn software, what would you recommend they do first? Or how would they approach it? How would you approach it if you were to just start from nothing right now?
Oh yeah. So if you're going to start from nothing, the thing that I would recommend is first, don't get intimidated by it. That's the very first thing because it seems like it has a high point of entry, but it really doesn't, especially considering um, how open some programmers are to sharing knowledge, like especially you. And because we went to what was Agile Open SoCal,
That's right.
right? And we did a talk about what did you call the talk?
It was impro style improv techniques for agile software teams.
Yeah, that's what it was called. And I helped you present that.
Yeah.
And going to that, because I had learned programming before, but I had never like pair programmed or anything like that, or which is like which was like a lot of what that whole conference was about was the whole agile thing. And going to that was very eye-opening of seeing how open a lot of people are. Because I could easily ask any question and it wouldn't be no matter how stupid I might think the question is, it wasn't stupid. Like no one ever made me feel like I was stupid.
Yeah.
So like the very first thing is like, don't get intimidated by it. And then the second thing is choose one language because there's a lot of languages. Choose one and then learn that first. Like learn as much as you can about that language before you start driving. Because I made that mistake a long time ago.
Okay.
Because I saw that there were so many languages that I was like, ooh, I'll start learning one and then I can start learning other ones too. Like at the same time. And I was like, no, that's a bad. As soon as I started doing it, I was like, that's a bad idea because it just became too overwhelming.
Yeah, it just gets
And that's when
confusing.
yeah, it just gets confusing. So that's why I started learning just Python. And then once I have I mean, I'm still learning Python.
You know,
Uh, so that those would be my two recommendations. There's
and
also like some good resources on the web for learning those.
yeah, there are tons. One bit of advice I have for you as well is don't wait until you think you know it. You're good enough to work or just work with the programming way before you think that you're good
Yeah,
enough. So jump before you're ready.
yeah, yeah, yeah.
Yeah. Cool. Oh, Puck90 asks, which language should you learn first? I mean, you say
Uh,
Python, right?
I learned Python strictly because I learned that it was named after Monty Python.
That's
So
true.
that's why which not a lot of people know actually. But I discovered that it was named after Monty Python, so I started learning that one first. But it
Yeah.
really kind of just like depends. Like there's no one right language, although some people might disagree.
Those people are wrong. There is no one
There's
right
no one
language.
right language.
No.
So I'm sorry to not give a definitive answer, but it's really just you kind of have to see which one works for you.
Yeah, but Python is a great place to start. Ruby is
I
another.
found Python to be very
Yeah,
easy entry.
yeah. There's a lot of documentation. It's really easy to Google things with it. Things generally make sense with Python. And once
Yeah,
you understand Python, like a lot of other languages start to make sense. You're like, oh, it's kind of like Python, except, oh, it's kind of like Python, except, you know, yeah.
yeah.
So, yeah, I mean, I'd agree with you. I mean, that was actually my first language too, was Python. So, yeah. Or
Although
technically
technically you could say
JavaScript.
my first language was HTML was mine technically.
Right. There are some who would argue that's not a programming
But
language.
I know that's why I'm saying technically
Yes.
because it's one of those ones where it's like it's not really a programming language even though it is because you're telling a computer to do something.
Yeah, it's not what some would call Turing complete, which is
Well,
fully decked out. You can do anything with this programming language. But
I don't care.
yeah, because it's just a lot of fancy talk. It doesn't matter. What matters is that you go and do stuff. So, okay, we're a little bit over time, but I do have a few things to say towards the end. First of all, I want to thank some people. My production liaison is Matt Pittner. My designer, Aaron Harvey, who has Infinite Trek on Saturdays. My marketer is Lucas Fanasic. He's on Two Liars tomorrow at 7, which, by the way, I'll be on that show also. So come and see me try to lie about my past on Two Liars. It's going to be great. My bot master is Cody Bushy, and he has a show called An Actor Unprepared. It will be back on September 14th. Music by Arlo Sanders and Alex Kahn, who do made-up music, which, by the way, is the next show to come on this channel. They're going to be up next, and I love to listen to them while I learn software on my own, because it's really great to have someone else doing something creative in the background that isn't exactly related to what I'm doing, but makes me feel like I'm part of a community. So, definitely check that out and stick around, clone the C code that you just saw today on CodingKoans, and, play around while you listen to Alex and Arlo jam. There are free VODs at FTL Talks, that's Foxtrot Tango Lima Talks, FTL Talks on YouTube. You can Google that, or you can subscribe and get those VODs right away on this channel and all the other benefits that come with this channel. So that's it that I have for all of my spiels. Doug, thank you so much. This has been an absolute joy. I miss
Welcome.
being in person with you. I really want to go back to Disneyland with you sometime.
Me too, man.
Don't poke your eye out this time.
No, I won't.
Okay. I'm
I'm
going
gonna
to
put
end
it
this.
right there.
All right. I'll see you, everybody. Bye.
I walk this life. The only steps I can. Steps too high. I'm just a man.
If you see my face at your hour of death, don't shake. Don't shake in your boots, no, don't you fret. Cause I'm gonna take you down where the beats are pumping. Down to hell where the lava's jumping. In the mountain, lava's jumping. Down to hell where the lava's jumping.
Let yourself fall, cause you'll only get higher. Let yourself drop like a beat on fire. Living half dead, so you might as well drop. The f***ers can't find you, the beat don't stop. The beat don't stop. It'll never stop.
I walk this life. The only steps I can. Steps too high. I'm just a man. I walk this life. The only steps I can. Steps too high. I'm just a man.
When you start saying a mountain is a mountain, a river is a river. Well, living's in, a mountain is not a mountain, a river is not a river. After learning Zen, a mountain is a mountain,